Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge. So what we are asked to do is basically just to design a hash set without using any built-in hash tables. So we can't use a Python dictionary. And then here we have of course, the add function to add a key to our hash set. We have contains to check if the key is in the hash set. And then we have remove to remove a key from our hash set. Right, so pretty straightforward. Now, the problem says that the key is between 0 to 10 to the power of 6. Okay, and we'll have at most 10 to the power of 4 calls. So how do we do this? Well, the simplest solution, because we know the keys are integers and they are between 0 and 10 to the power of 6. This is not efficient and not the actual way HashSet is implemented. It's not implemented this way, but as a start for solving this easy problem, it's definitely valid. Since we only need the keys 0 to 10 to the power of 6, right? What we can do is just create a Boolean array, right? That will mark a position as false or true depending on whether the value is in the hash set or not, okay? That way, if we want to add a key, we can just mark it as true. If when we remove it, we mark the position as false. And we want to check contain, we check if the position is true. Right, so that would be something like let's just do it like this. So it would be something like this here. We want to initialize it to false first for all of them. So this is going to be for all the values in the range of 10 to the power of 6. Okay, and then here we want to do self.values of key. And we want to assign, say true, because we just added it. And here we want to say false because we are removing it, okay? And if we want to check if it's present, we can just return whether it's present or not, okay? Now this has a lot of space overhead, but it should pass, except here the index is out of range. Yep, because we need 10 to the power of 6 plus 1 to reach, if we get a value of 10 to the power of 6, to have it in index, then we need to add plus 1 here in Python. So let's run it again, let's submit, and this passes, okay? Okay, so now let's see how we can reduce this space. So the key idea here is to use buckets, right? So basically, before we were using 10 to the power of 6, right? And so to reduce that space, let's just use maybe 10,000, right? You could also do 1,000, but whenever we get a key, right, to be able to fit it in one of the buckets here, so let's have 10,000 buckets. By buckets, I mean just lists, right? And whenever we have a key, we will just do modulo 10,000, and that will give us the bucket index that we want to put it in, and then we'll just add it to that bucket. So what does this mean? Let's take a smaller number just to understand here. So let's say we have only 10 buckets. And this maps to a bigger number, but 10 buckets, just so that it's easier for us. So if we have the keys equal to 9, then we'll put it in bucket 9. So we'd have like 10 buckets. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this should be 3, 5, and then 3, 5. Okay, and so when we get 9, we'll just go to the 9th bucket here, index 9. So our indexes would be 1, 2, 3, 4, 5, 6. Okay, so 4, 6, and then sorry about this, and then we'd have 7, 8, 9. Okay, so something like this. Okay, so when we get the key 9, right? Here, just to make the buckets work a little bit nicer, right? We can have number from we can number 10 like this. Okay, it's fine. So we can put it here. Okay, so we'll put our value here, so that would be just 9. Now what if we get, let's say, 11? Okay, so we'll do 11 modulo 10. That will give us 1, so we'll put 11 here. Okay, so that's sort of the idea. If we get key equal to maybe 19, then if we do modulo 10, we'll get 9, so we'll put 19 here. And then if we get, so you can see when there is when the value is in a key that has already another value, we'll put it in the list, right? And this is what sort of the main issue with HashSet and HashMap is to handle collisions, and the fact that 9 and 19 here are both in the same position, this is what the collision was, but how we handle it can be done differently in different implementation. In our implementation here, we are just using a list, but in some other implementation you could use a linked list, because removal in linked list is a lot faster. So that's sort of the main idea here. And then now if we get, let's say, key is equal to 13, then we'll, maybe 23 even, we do modulo to 10, right? We'll get 3. And so we'll put it in position, I think 3 here, okay? So I'll put it here, 23. And now, so you can see the insertion should work fine now. But what about the removal? Well, same thing, we go backward. So if we want to remove key equal to 11, again, we do modulo 10. We find the bucket index. So the bucket's index would be 1. So we find it here, and then we look for it in the list and remove it. If we want to check if it's there, similarly, let's say for 11, we do modulo 10, we find the bucket index, and then we search in the bucket, right? So here maybe there were multiple values like 14, maybe there was here like 1, sorry, this is 21, 31, right? Then to search for this 11, we just search if it's in the list, okay? So that's the main idea behind the solution. Now let's code it up. So we need buckets. So let's first say the size of our buckets is going to be 10,000 in this case here. And so let's just 10,000. We'll do +1 to fit the last one. And this is now false. We want a list for each bucket. And then what we want to do next is basically just here, we want to get the bucket index to know where to add it, right? And so to do that, well, we just need the bucket. And let's call it, let's create a function to give us the index, okay? So let's create a function to give us the index for a key. And so for that function, what do we need to get the index? Well, we just need to get the key modulo the number of buckets first, okay? So that gives us the bucket index, okay? And then in the bucket, once we get the bucket, so it's going to be just like, let's call these buckets actually. So we are going to take self.buckets here. And we get the bucket itself. And now to search for the element key, we just go through the list in that bucket. So let's just say I in the bucket. Now if the element is equal to the key, we found it, then we want to return the index I. But we also want to get the bucket index. So let's have this written both, the bucket index and then the index of the element itself. Now if we are not able to find it in the bucket, then it's not there. So let's just return something that says that the element is not there. So maybe we can just return -1. So now with this index function, it's easy to change this here. So what do we need to add an element? So we'll get to add an element, since it's not there, we'll get a -1. But we can still call index to get the bucket index. So let's call index to get the bucket index. So here we'll get the bucket index, and then let's ignore the other value because we don't need it. And so we can just append to this bucket, right? We can just append the key. So this would be self.buckets. Okay. But I think here the problem says, let's see, the problem says for add to insert the value. But this is a hash set, so if the value is there, maybe we want to just not add it, right? So to do that, we can just check if the value is there. So key was already there, then we can just skip. Okay. Okay, so this is how we handle the add. Now how do we handle the remove? we can do the same similar thing here. So we want to go and remove position at position I, or remove the key. So in a list, you could just remove the key itself like this, the value itself. Okay, so how do we implement checking if the value exists? Well, again, we need to check the index, right? So, and then we just check. Remember, if it's not there, we'll return -1. So if it's not there, if it's there, then the index would be positive, bigger or equal to 0. If it's there, the index would be bigger or equal to 0. If it's not there, it would be -1. We could also just do different than -1 here. Okay. Either that, or we can do this. Okay, so now let's run this and see if it works. Looks good. So basically, the main idea here is using the modulo to get a bucket. Then the bucket, we add the elements in a list, and so to search for them, we do it this way by just going through the list. If we wanted to, we could use a sorted list as well. That's another option to keep the list sorted and to sort of binary search to search for the element. That's also another option. So let's submit this. Looks like there's a problem here. Let's see. Okay, so in remove here, we want to check if the element is there before removing it, right? Because if it's not there, we don't want to remove it. So how do we know if it's not there? We can just check if the index is equal to -1, then we don't want to remove anything that's not there. So let's just fix that. Submit, and this passes. Okay. Yeah, so that's sort of a better implementation. As an exercise, you could also try to solve it with linked list. Yeah, that's pretty much it. Thanks for watching, and see you on the next one. Bye.